Okay, this is a couple more sequences here, a bit more unusual, and these can't always be found by finding the common differences, not always. So I've got this one called the Fibonacci numbers, for the Fibonacci sequence. Fibonacci was an Italian mathematician born in the 13th century, 12th century, 13th century, and he came up with this sequence. And it's very straightforward, and it's another one worth remembering. And basically, if we take 1 and 1, we make 2. If we add 1 and 2, we make 3. If we add 2 and 3, we get the next term. So if I want the next one, I'm just going to take the previous two terms, add them together to get 34. And the next one will be 21 and 34, giving me 55. And these are Fibonacci. One thing to look out for, we don't have to start with this. You could start with any number you like. So you could start with the number 4 and 6. So long as you've got 2 to start with, just choose them like that. And so we now can make our sequence. 4 and 6 make 10. 6 and 10 make 16. 10 and 16 make 26, 42, etc. And this is called the Fibonacci sequence or Fibonacci numbers. The one here is the classic Fibonacci. Another set of numbers you might want to know about are things called geometric. Now in linear, we always added on the same each time, but with geometric, it's about multiplication. So look at this. You multiply by, always the same number with these. We're always multiplying by 2. So this one becomes, this first set of numbers, because we're multiplying by 2, we're going to write 2 down, and we're going to write 2n. 2 to the power of 1, 2. 2 to the power of 2, 2 squared. 2 to the power of 3, 8. Again, a nice one to try and remember when you get that. Let's have a look at this one. It's another geometric. What am I timesing by each time? Well, I'm timesing by 3. So I was timesing by 2 here, and I made it 2n. This one I'm timesing by 3, so I'm just going to make it 3n. But when I check it, 3 to the power of 1 is not 1. 3 squared is here. 3 to the power of 1 is here. 3 to the power of squared, so when 2 is the third number. 3 to the power of 3 is 27, that's the fourth number. So although it's got the base of this, I'm actually going to take away 1 from here. So I'm going to go 1, take away 1, 3 to the power of 0, 1. 3 to the power of 2, take away 1, 3. 3 to the power of 3, take away 1, so 3 squared gives me 9. So we can use this as the base, and then we might have to adjust it slightly. Now don't worry too much about the geometric numbers, they're not going to be that common until we come up to IB. So this is just 2 more types of sequences that are non-linear or quadratic. You've got the Fibonacci and geometric.